Hi, this instructional video is about graphing exponential function that have asymptotal behaviors. Gotta love these kids. So I threw them a little above their level, exponential functions, and they went crazy. No, not like a riot. They wanted to know how to actually graph these things. Thank you so much. Here, let me demonstrate with using number 1, and you could try or compare as I go with number 2 and see if you could do it on your own, okay? Now, to graph this type of exponential function, what we call this, when we have an extra elements here next to the exponent and a constant, this is part of a thing called general exponential function. And the general exponential function is listed as y is equal to a coefficient a times the base raised to an exponent x with a shifting of a number plus the k. And the h and the k, they define the horizontal and the vertical shift. Okay, and remember, it's an inverse, okay? So even though it's listed as a minus h, it's given as a positive h for this coordinate right here. It's not a coordinate, but the pair of numbers. All right, so let me demonstrate how that works out over here. What we have is a coefficient 3. What we want to do is either way, it's going to be the same. What's going to be the different is going to be the shift, horizontal and the vertical. So we're going to just graph this part. We're going to just graph the coefficient, the base, and the exponent without the shift yet. And to do that, we're going to use a table of values. You've done that before. And this easy number to put in to see how this looks like is 0, 1, 2, negative 1, and negative 2. And if you put a 0 in here, 2 raised to a 0 is a 1. So let's do that over here. 2 to the 0 power is just simply 3 times 1. So it's going to be a 3. If I put a 1 in here, 2 raised to a first power, that's 3 times 2. So that's going to be a 6. And suddenly from that point on, you could see that it's going to grow exponentially. 2 squared is 4. 4 times the coefficient 3 is 12. Boom! Now let's go look at the other side on the number line, negative 1. And as you know, when you have a negative exponent, you have to write it as a positive exponent. So this base goes downstairs. So it becomes 3 over 2. To the first power, just 3 over 2. And then if you put a negative 2, you can see right away that this is going to be written as 3 over 2 to the second power positive, which becomes 4. So it's getting smaller and smaller. It's becoming closer and closer to a 0. Oh, not a 0, I mean. Yeah, 0. But it's 3/4 here, okay? Now, to graph this, here's what it looks like. The coordinates are 0 and 3. 0, 1, 2, 3. Boom. That's the y-intercept at 0 and 3. And when I put a x equals 1, y is going to be 6. 3, 4, 5, 6. Boom. 1 and 6. And 2 is going to be 6, 12. So it's going to get big really fast. And on the other side of the number line, negative 1 is going to give me 1 and 1/2. So around here somewhere. And negative 2 is going to give me less than 1 at 3/4. So it's decreasing as x is decreasing. Like that. And so the y-intercept is right here. And the asymptote is y is equal to 0. That's the asymptotal line that it tries to get to but never actually becomes a 0.